All right, on page 552, we're going to be talking about special right triangles. There's two kinds of special right triangles that we always deal with in geometry. 45, 45, 90, those are the degree measures, and 30, 60, 90. All right, since each of those have a 90, they're both right triangles. All right, and what's special about them is that they're very useful, and they got used a lot over the years. So, you know, like we've talked about before, mathematicians are fairly bright people. They started figuring some things out, okay? Now, at 45, 45, 90, since two of those angles are congruent, doesn't that mean two of the sides are congruent? So the legs are congruent in a 45, 45, 90. That's the only isosceles right triangle. So you'll hear these described different ways. It's a 45, 45, 90. It's an isosceles right triangle. It's a right triangle where the legs are congruent. All right? Now, that's what we're going to concentrate on today. Tomorrow, we'll deal with the 30, 60, 90. Now, in a 45, 45, 90, since we know, well, let me read this first paragraph too. It says the diagonal of a square forms two congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 90 divided by 2, which is 45. So such a triangle is known as a 45, 45, 90 triangle. They will give you problems where they'll tell you where it starts off a square. You're going to be expected to realize, oh, if I draw a diagonal in, I've turned it into two different 45, 45, 90 triangles. Actually, two congruent 45, 45, 90 triangles. Okay? Now, since the legs are congruent, they call the length of each leg L. They're being really inventive here. L for leg. And they call the hypotenuse H for hypotenuse. And then you can use the Pythagorean theorem, and you can solve for L in terms of H, or you can solve for H in terms of L. Either way. So look, the Pythagorean theorem tells us that one leg squared plus the other leg squared equals the hypotenuse squared. So L squared plus L squared is 2L squared. To solve this for H, take the square root of both sides. All right? Now, something that you're not as familiar with now as you will be later, when we take the square root of 2L squared, square roots work this way. I can think of that as the square root of 2 times the square root of L squared. Well, we know what the square root of L squared is, don't we? The square root and the exponent of 2 are inverse operations. They undo each other. So it's the square root of 2 times L. Now, it's conventional to write anything that's not supposed to be underneath the square root in front of the square root. Because otherwise, if I write it like that, it's kind of hard to tell. Is the L under the square root or not? So to solve that dilemma, since the L's not under the square root, we write it in front. So that's an algebraic proof to prove that whatever the length of a leg is times the square root of 2, that's the hypotenuse. So for instance, if the length of the leg, and I'm going to say the leg because the legs are congruent to each other, if the length of the leg is 5, then the length of the hypotenuse is 5 times the square root of 2. I don't have to rework the Pythagorean theorem. That's what it's going to equal. Okay? Now, here's our theorem for 45, 45, 90 triangle. It tells us that the hypotenuse equals the leg times the square root of 2. Okay? Which we just really did an algebraic proof of. What I want in your notes is this. So, in your notebook, start by copying this. Label this 45, 45, 90 right triangle. I know, having the 90 and saying right, sort of redundant. Again. Label each leg, leg. Label the hypotenuse, hypotenuse. Label the right angle as a right angle, and the other two angles as 45. All right, so we just got through proving that the hypotenuse equals the leg times the square root of 2. Now, the book uses H and L, and I do a little bit more because over the years I've realized that students sometimes, amazingly enough, forget what the H stands for and what the L stands for. So hypotenuse equals leg times the square root of 2. Now, if you've got that, but if instead of having a formula to find the hypotenuse, you wanted a formula, what if you know the hypotenuse and you're trying to find the leg? So we can make this into a formula to find the length of the leg. Since that's an equation, can't I divide both sides by the square root of 2? And if I divide both sides by the square root of 2, don't I get hypotenuse divided by square root of 2 on one side and leg on the other? So the leg equals the hypotenuse divided by the square root of 2. So if we know that the hypotenuse is, let's say, 58, then the length of the leg is 58 divided by the square root of 2. And I probably should have had this first, but don't forget that in a 45, 45, 90, the leg equals leg. The legs are congruent. Those lengths are the same. Now, you're going to need to commit that to memory, all right, because we're going to use it. We're going to use it a lot. So you don't need to be trying to take time to look it up. You'll memorize it more or less accidentally. Hopefully we'll use it enough, okay? But commit that to memory. All right, now, I picked a few here from page 553 for us to do. So you don't have to draw the figure, but, you know, number 1A, maybe make yourself a note. This is from page 553 because there just weren't enough examples from the assignment. We need lots of examples. This is the kind of thing that becomes really easy when you do enough of it. So, number 1A. First, we need to identify, make sure this is a 45, 45, 90 triangle before we use the properties of a 45, 45, 90 triangle. I see the right angle, I see one 45-degree angle. Well, doesn't the missing one have to be 45? Has to. So, fill it in if you want, I don't care. The length of one leg is 4. That means the length of both legs is 4. We're supposed to find X. Can't I find it using that right there? X represents the hypotenuse. So hypotenuse equals the leg times the square root of 2. And leave it like that. We're done. It's not wrong if you type that in your calculator and get a decimal, but just leave it like that. Okay? Wow, it was easier than you thought it was going to be, wasn't it? All right. 1B. X is the hypotenuse again. Hypotenuse. Well, is it a 45, 45, 90? Yeah, because if you have a right triangle where the legs are congruent, it's a 45, 45, 90. So we're using this again. Hypotenuse equals leg times the square root of 2. And on 1C, we're actually going to get to simplify a little bit. We're still using this. Hypotenuse equals leg times the square root of 2. Hypotenuse X equals the leg, 7 times the square root of 2, times square root of 2. Now, I do want you to simplify this because you don't need a calculator. You don't need to be an expert on how to work with radicals. What's the square root of 2 times the square root of 2? 2. It's just like the square root of 2 squared, isn't it? So it's 2. And there we are. Everybody follow me on why the square root of 2 times the square root of 2 is 2? Because square root of 2 times square root of 2 is the same thing as the square root of 2 squared, the square root, and the exponent of 2 cancel each other out. There we go. All right? Okay. Let's try these. Now, these are also from page 553. They're more towards the middle of the page there. I think I'll knock both these out at once. They're both 45, 45, 90s. 2A, I can tell because both legs are labeled X, so it's an isosceles right triangle. It's 45, 45, 90. 2B, a 90 and a 45. The missing angle's got to be 45, so there we go. Now, on 2A, the leg is called X, so I'm going to use this. Leg equals, X equals, the hypotenuse is 5 square root of 2, divided by the square root of 2. Now, a lot of the times when we get here, we'll be done. Because, like if that was an 11 as our numerator, there's no need to go to the calculator and see what 11 divided by the square root of 2 is. But on this one, take a wild guess. What do you think the square root of 2 divided by the square root of 2 is? It's 1. It's not 2. It's 1. Because any number divided by itself equals 1. So square root of 2 divided by square root of 2 is 1. So we get 5. All right? On 2B, we're looking for the leg. Leg X equals hypotenuse 18 divided by the square root of 2. You're done. There's no need to go to your calculator and punch that in. It's not wrong if you do, but there's no need to do it. Now let me caution you about something. That's not going to be the answer you see in the back of the book, because this book puts all the answers in simplest radical form, and I haven't taught you how to put your answers in simplest radical form. So the book says the answer is this, so you might think, well, crud, now I can't tell if I got it right or not. Well, sure you can. You take our answer of 18 divided by the square root of 2, and say, okay, it's that. You take their answer of 9 times the square root of 2. Oh, it's the same thing. So yes, I did get it right. Okay? All right, what do you think? Can you work with 45, 45, 90s? Let's see if you can. Do number 1 from page 556. You get 5 times the square root of 2. All right, you identified it as a 45, 45, 90. Then you say, okay, I know what the leg is. I'm looking for the hypotenuse. So the top equation, the one I circled, is the easiest one to use. So the hypotenuse, X, equals the leg, 5, times the square root of 2. All right? Number 2. Go ahead. Did you get what I got? All right, you can tell it's a 45, 45, 90. You know the hypotenuse. You're looking for the leg. So the second equation is the easiest one to use. So leg, X, equals hypotenuse, 14, divided by square root of 2. All right, on number 3, let's work this one together because we need to make sure we can simplify this one right. We do have a 45, 45, 90. We're looking for the hypotenuse, so I'm going to use this equation. Hypotenuse, x equals a leg, 11 square root of 2, times the square root of 2. Now, they're going to do this to us fairly often, so we got to get used to this. The square root of 2 times the square root of 2 equals 2. So our final answer is 22. All right, everybody still with me? Number 14. So jump ahead a little bit. If a 45, 45, 90 triangle has a hypotenuse length of 9, find the leg length. Well, I don't know. I guess they think they're being tricky by writing it out in a sentence instead of giving you a picture of it. But they tell us it's a 45, 45, 90. So we know that all these apply. They tell us what the hypotenuse is. They ask us for the leg. So aren't we going to use that? So leg equals hypotenuse divided by square root of 2. And that's that. Any questions? Okie dokie. So page 556, and it's all chopped up because we're just doing the 45, 45, 90s today. So write this down fairly carefully. 1 through 3, or it's on your learning target sheet. 8 through 17, 28, 29, 31, 33, 36, 38, 47, 57, 59, 61.